Dear colleagues, we are glad to present for you our research cloud resource use the students' project activities. The modern educational system recommends learn aimed of acquiring practical skills and based on the activity approach. Educational research products are the necessary component of curricula of physics, computer science, biology, and chemistry. There is a problem of specialized equipment and facilitates using for the implementation of such products in distance learning. Therefore, the issue of cloud resource using of distance learning organization in robotics is relevant. Due to the pandemic, and all educational institutes have to transfer the activities in online and conduct distantly. Cloud interpretation tools, especially visual communication, have become relevant. Interaction during such classes in group projects of events has own specifiers. Cloud technologies will transform the educational process and apply new methods of technologies, taking into account the use of technologies in educational and extracurricular activities. In distance learning, it becomes problematic to conduct such classes. The ability to components and electronic device in sockets. Thus, their factors lead to decreasing the number of children involved in robotics and a gradual loss of interest. Therefore, today is an important task to adapt robotics classes to the distance format, as well as to support teachers who use educational robotics in the educational process. Distant classes robotics require effective organization of the educational process. It is due to the particulars of the performed activity, research, development of the model description of robotics system, organization of external activities, statistical processing of empirical data, etc. The study of robotics transforming showed the project activities has staged organization, acquaintance with the topic, definition of goals and objectives, communicate, determine the source of information, ways to collect and analyze information, building of solution, determine the final products of the project, developing special interactive section of course, instruction on how to search information. The course can include dynamic links to database. It's possible quickly and effectively to find the material. In general, all stages can be implemented of the distance learning platform, such as Moodle or Google Classroom. But the stage of the project requires special means. In the review of 45 publication of the students' practical activity organization, concluded in most cases, all these men can be divided into the 5 categories: electronic components, crafting materials, devices, toolkits, software. The problem of project developments in robotic system in Ukraine is quite new. In the scientific work, Ukrainian scientists, this topic is presented in a separate publication. The issue of cloud technology possibilities for the distance learning in robotics is not sufficiently relevant in a scientific publication. Cloud technologies allow organization robotics training distantly. Tinkercad program attract special attention. It's a free online 3D modeling program. Developed electronic circuits ability appeared only in 2017, so this further new for teachers. Since then, the program has guaranteed popularity among teachers of robotics. Tinkercad has advanced capabilities for use in lesson. It has a number of scientific advantages. Tinkercad supports automatization at the level of separation of teacher and students. As the teachers has access to students' accounts, he can moderate and comment. It's make the possibility to enable to save model for any of the moderated students. This model prevents students from viewing or creating comments on Tinkercad designs and limits their gallery view to a curated list of design approved by teachers. The class gallery allows setting all students' projects at once. In addition, students can each other products and practice of their discussion. Ability to share projects with the friends. Public projects can be integrated into another project by following the link. Such integration is an important element of the interface usability. As a difficult advantage in the teacher's ability to develop separate classes and the function of integration with Google Classroom, public Tinkercad design can now be shared or assigned at homework using the popular Google Classroom platform. Or contains a library of ready-to-use lesson plans. It contains a sufficiently complete basic set of electronic devices, sensors, and motors for modeling electronic circuits based on the Arduino microcontroller. It supports modeling, programming, reproduction of work of devices, the monitor of output of information, and the monitor diagrams construction, a mode of making up the electronic circuit set. It contains grouping of projects in different folders. This approach allows making a distinction between didactic materials for different topics and subjects. It has share editing of electrical circuit, provide share access to the project, make contribution of organization, teamwork of students. It is also possible for the teachers to view and edit students' data. Tinkercad supports C++ programming language for Arduino. It's also possible to develop software in the Visual Programming Editor code blocks. This further allows conducting classes for younger students. Visual programming commands like Scratch support drag-and-drop technology. It simplifies the process of programming development. The mode of electronic circuit set of devices automatically develops the list of components that we used in the constructed circuit. It helps quickly to estimate the number of items and their cost. It's possible to export the table of CSV SPIT format. A scientific advantage of Tinkercad is ability to demonstrate the appearance of the electronic circuit. There are special modes mode simulation in which the electronic circuit begins to work. In this mode, it can be verified the device connection are correct and the application is working appropriately. Among the disadvantages of Tinkercad are the simulated physical parameters of the electronics in the programming work perfectly without noise and external influences. It does not accurately cover the process of setting up a real electronic element. The following types of errors of malfunctions of the student's work are possible during the work of the electronics device development. At the stage of physical model of device development, incorrect correction of elements, lack of contact of the circuit, broken wire, malfunction codes of batteries or electronic components, etc. No elements to initialization, incorrect program code. The process of assembling and connecting the electronic circuit requires control over the contact and closure of the electric circuit. The simulation environment also eliminates elements of accident device feature. Such features must be checked by the special tester. Such errors often occur in students of real electronic circuit making Therefore, in the Tinkercad Cloud environment, prototypes of electronic devices test the hypothesis about the structure and connecting of project components. Variants of device management programs can be developed, but in the course materials creating, we need to assign out projects that consist of devices that are in the Tinkercad library. Use of Tinkercad is due to several reasons. First, the lack of access to robotics designs due to poor logistic or pandemic. Second, there is the ability to create a model and test it to further acquire the necessary components for independent research. The teacher has the opportunity to organize work in the project, interactive task in the Google Classroom, create a gallery of works, and organize a discussion of components of ideas, their implementation. The teacher's work should take into account formulation of the project task, organization of discussion of ways to solve the problem, highlights the consequence of the project, checking the results of the project, forming a response. Thus, the use of Tinkercad in robotics classes engages students in activity and simulated additional motivation to develop projects. The project testing model will provide saving in the purchase of electronics components at the expense of modeling of the project in the cloud. Carry out of experimental and research work is provided. Thank you for your attention.